In Unit 11, we really take integration to the next level. In 6.1, we're going to find the area between two curves. Then we're going to find the volume of revolution using the disk and washer method. And finally, we'll look at volume of a solid using a different method called slicing. The area A of a region enclosed by the graph y equals f of x and y equals g of x. So here's f of x, and then there's g of x. And the area enclosed between them, this area A, also enclosed by the lines x equals a and x equals b, where f and g are continuous functions on the interval, and f is greater than g, so it's above here, for all numbers x. Then the area goes from the integral from a to b, f of x minus g of x, oops, I forgot dx. So that's how we're going to find the area between two curves. We're going to take the top function minus the lower function, and then we're going to use the two endpoints as our integrals. So let's take a look at this example. This top function is e to the x, and this lower function is the square root of x. My line over here is x equals 0, and my line over here is x equals 1. So we're looking for this area in between. So we integrate between 0 and 1, the top function, e to the x, minus the lower function, the square root of x, dx. Now we've had a lot of practice integrating this, but we could use a little bit more. So we'll rewrite the square root of x as x to the 1/2, integral from 0 to 1, e to the x minus x to the 1/2 dx, and then we'll find the antiderivative of each piece. So e to the x is just e to the x. We add 1 to the exponent, so it becomes 3 over 2. We multiply by the reciprocal of 2/3, evaluated from 0 to 1. So that's e to the 1 minus 2/3 times 1 to the 3/2 minus e to the 0 minus 2/3 times 0 to the 3/2. So that's going to be e, and then minus 2/3, and then e to the 0 is 1, and 2/3 times 0 is just 0. So it's e minus 2/3 minus 1, so that's going to be 5/3. So e minus 5/3 is the area in between those two graphs. Let's take a look at another example. This is example 4 on page 470. It says find the area of the region of the graph y equals x squared minus 4, the x-axis, so we're just looking at it between here, and the lines x equals 0 and x equals 5. So we're looking here and then here. So we're looking for this area and this area. So notice that we have some piece of the area that's under the curve and then some piece of the area that's above the curve. So we're going to need to use two different equations to find that. The first thing we need to do is figure out where this intersection point is right here. So we're going to set x squared minus 4 equal to 0, because that's the x-axis. Then we're going to solve. That happens at x squared equals 4. So when we solve this, we get x equals 2 and x equals negative 2. Now negative 2 is on the other side over here, so we don't need to worry about that one. X equals 2 is the one we're looking for right here. So our first integral is going to go from 0 to 2. We go from the bigger function to the smaller function, so that's going to be 0 minus x squared minus 4 dx. So that's this first area. We'll call that area 1. So just to be clear, this is area 1 right here. So let's work on integrating that. We'll go from 0 to 2. That's negative x squared plus 4 dx. So it's negative 1/3 x cubed plus 4x, evaluated from 0 to 2. So that will be negative 1/3 times 2 cubed plus 4 times 2 minus 0. So negative 8/3 plus 8. Let's see, we'll make that over 3. So that's 24. 16/3. So this first area in red is 16/3. Now we'll find the other area over here. Let's see, we'll color that one in blue. And when we'll find that, then we'll add it to the area 1. So let's call this one area 2. So area 2 is going to go from 2, our point of intersection, to 4, to 5, our other axis, that point that they're giving us. And again, it's going to be the top function minus the bottom function. All right, so top function minus bottom function is x squared minus 4, and then minus 0, because this is the function x equals 0. So that's not really going to affect us. So we have the integral from 2 to 5 of x squared minus 4 dx. So that's 1/3 x cubed minus 4x between 2 and 5. 1/3 times 5 cubed minus 4 times 5 minus 1/3 times 2 cubed minus 4 times 2. All right, let's simplify that. So we get 125 over 3 minus 20 minus 8 over 3 plus 8. Let's see, that's negative 16. And 125 minus 8, that'll be 117 over 3. All right, we'll put that over 3. So we get negative 48 over 3. And then 117 minus 48 is 69 over 3. And then 3 goes into 69 23 times. So now I have my total areas are going to be, let's go back to black, 16/3, and I could say 69/3. That would probably be easier than rechanging it. So we'll have area 1 plus area 2 is 69 over 3 plus 16 over 3. So 69 plus 16 is 85/3. So this total area between the two the red and the blue, is 85/3. Let's jump up to example 7 on page 473. It says, find the area of the region enclosed by the graph y equals ln of x. So this is ln of x. The x-axis and the line x equals e. So we're closing it between here and here. So, and this graph. So we're looking for this area right in here. So the first thing we have to do is figure out, where is this point of intersection? Where does ln x intersect with the x-axis? So we'll set them equal to each other. Ln x, and the x-axis is 0. So we take the e of both sides, and this just becomes x equals e to the 0, and anything to the 0 power is 1. So this happens at the point x equals 1. The next one they told us is the line x equals e, so this one's x equals e. So now my integral is going to go from 1 to e, and the function that I have is ln x minus, the other function is x equals 0, so it's not super important that you write it that way, but I just want to make sure that you understand where all these pieces are coming from. So that's the integral from 0 to e of ln x dx. We take the antiderivative of ln x. Now you see we've come to an impasse here. I don't know the antiderivative of ln x. So what we're going to need to do is change the variables. What I mean by that is, instead of integrating with respect to x, we're going to need to integrate with respect to y. So let's take a second and redo this equation. So right now we have y equals ln x, but I need it to be x equals something. So we'll take the e of both sides, and those will cancel, and I get x equals e to the y. So another way of writing this function here is, instead of saying y equals ln x, I could also say x equals e to the y. Now let's find our points that we need for intersection. So we know this point happens at 1, 0, so I'm going to take the y value, and I know this point happens at e, 1, so I'm going to take the y value. Now let's rewrite what we have. We're going to go for the integral from 0 to 1, And we're going to be traveling towards the y-axis. So it's this first one of e minus e of y dy. And now this I do know how to take the antiderivative of. E is just ey, and e to the y is just e to the y between 0 and 1. So this first e was like a constant. So a constant, when we integrate, we just get the variable and times it. So now let's plug in. We have e times 1 minus e to the 1 minus e times 0 minus e to the 0. So that's going to be e minus e minus 0 minus 1. Oops, plus 1 minus a minus 1. So that's going to be an area of 1. So while we took something that looked really difficult, we were able to rewrite it in respect to the y-axis and find something a lot easier. This is kind of like a higher level skill, but it's important to know, especially when we get into the next unit, for volume of rotation.